Okay, so this is like a rough curriculum. I might be adding to it. I'll definitely be covering everything on here, but there might be more that we're going to cover. But I'll just go over this quickly. So we're going to talk about what is a glaze, like what a glaze is made of. We're going to get into the periodic table of elements to understand like which elements are used in glazes and start learning some chemistry. And then we're going to talk about the glaze materials themselves and how they relate to chemistry. So the glaze recipe ingredients, glass formers, stiffeners, and fluxes. Those are the basic components of a glaze recipe. So we're going to talk about those, how they relate to each other. We're going to talk about the difference between cone 10, cone 6, and cone 04, and how you can raise and lower firing temperatures. A very basic intro into chemistry. So I don't have a chemistry background myself, like aside from what I learned through Alfred. Chemistry was my favorite subject in high school, and I went to Camosun College here in Victoria for first year of like an applied chemistry program when I was like straight out of high school. And then I quit college to go travel the world and kind of never got back to it until I ended up in art school. So I really love chemistry. I always kind of had this connection with learning chemistry. So I'm going to teach you like the basics of atoms and molecules, but just understand that like I don't have a degree in chemistry. And that might help a lot of you because I'm going to teach it the way I understand it. And it might be more simple for you to understand because I'm going to teach it in a way where it relates to glazes. And that's basically like the extent of my chemistry knowledge is how it relates to glazes. So you'll have to bear with me if any of you have chemistry backgrounds. I welcome any sort of feedback on my teaching of chemistry. So then we're going to talk about the unity molecular formula, which is basically it takes a glaze recipe, so all the materials in a glaze, and it breaks them down into their elements. So we've got like silica, alumina, boron, there's calcium and sodium, like those are the fluxes. So we're gonna, that's what the unity molecular formula does, is it takes all these ingredients and then it shows us the chemistry of that combination of ingredients. And that's the basis of everything we're going to use to understand and to manipulate and change and fix glaze recipes. And then glaze calculation software will help us to just input a recipe and then it spits out the UMF so that we don't have to do all the math. Although I will show you how the math of calculating the unity molecular formula, I will show you that just because when you understand how to go from a glaze recipe to the unity molecular formula, that helps you to kind of understand when you add a little bit of this, how things change. So I will show you the math, but I won't require you to ever do the math. It'll just be kind of like in the back of your mind, just as a further deeper understanding. Then we're going to talk about glaze durability, which is related to food safety, but they're not exactly the same thing. But basically, the more durable a glaze is, the more it can withstand the tests of time, like the abuses that we put it through, going through the dishwasher, using cutlery, stacking plates, filling with orange juice, that sort of thing. The more durable a glaze is, the less likely it's able to leach toxins into our food, which could then be poisonous to us. So we're going to talk about that and how to best, like how to make sure that you have the most durable glaze possible, kind of in theory. You can go get, like, you can't really look at a formula and know that a glaze is going to be food safe 100% without having it tested, but I'll give you enough information to make good choices and good decisions, and like kind of like make the best possible durable glaze on paper so that it's least likely to cause issues down the road. The stall chart, we're going to use that a lot, and I'll, if you haven't seen it, I'll show it to you in a little bit. But that's basically, it's a chart where you can plot your glaze recipe on the chart, and then you can move around the chart, and you can, like if you move a little to the left, you go from glossy to matte. And if you move up, you're increasing temperature. And if you move down, you're kind of decreasing temperature, like the melting temperature. So that chart is really handy. So we're going to talk a lot about that. We're going to use the UMF to do material substitutions. So basically, you can take the chemical formula of a glaze. The glaze doesn't really care where it gets all of the components from, like silica. It doesn't care if it gets silica from feldspar or from talc or from just straight up powdered silica. It all kind of goes into a pot and melts together. And so you can substitute one material for another as long as the chemistry of the two glazes end up matching in the end. So I'm going to show you how to do that. And then we're going to use chemistry to fix common glaze flaws. Running underfired glazes. There's a lot of underfired matte glazes out there, like matte glazes that aren't true matte glazes. They're just underfired glossy glazes. So we're going to learn how to prevent that. Crazing, I'm going to show you how to talk about thermal expansion and how to take a recipe and that's crazing, and what you might want to do to it to reduce the crazing. And crazing is always clay body dependent, so it's not always a glaze. It isn't always going to craze on every clay body, but if you have a glaze that crazes on your clay body, then there are ways you can manipulate that glaze formula to reduce the thermal expansion and then hopefully eliminate the crazing. And then colorants and opacifiers. So we're going to finally, after we studied all the chemistry of glazes without colorants, then I'm going to show you how the chemistry of the base glaze affects how the colorants turn out. So copper could turn out blue or green or somewhere, or turquoise or somewhere in between, depending on the UMF of the glaze, and it actually depends on which fluxes are used in the glaze and some other things. So we're going to talk about all of that.